In computers, it will be required by us to be using both positive and negative numbers. In fact, in real life, we use both positive and negative numbers. Since we have both positive and negative numbers, we need to have a way of representing positive and negative numbers in a computer. Normally in maths, if I have to say 20, I'll say plus 20 minus 20 with a symbol. But in computers, everything is ones and zeros. So I cannot use the plus and minus symbol to represent a number. So what do I do is, in order to represent positive and negative numbers, the researchers have discovered three ways of trying to represent them. The first is the sign and magnitude method. The second is ones complement. Because of drawbacks in ones complement, most of the computers today use the 2's complement method of representing negative numbers. So let's first try to understand what is the sign and magnitude way of representing a negative number. So first thing you need to understand is, when I talk about the word sign, I really mean, when I talk about the word signed number, I mean a number which can be both be positive or negative. When I say unsigned, the number is only or always positive. I'll repeat. Unsigned means a number is always positive. Signed means a number may be positive or it may be negative. Let's take a look at a number like say 83. 83 in binary is this particular value. Now, since it is plus 83, what I am doing is I am using the leftmost bit and indicating it as 0 to indicating that this fellow is plus 83. So out of the 8 bits, I am using 7 bits to represent the size or magnitude of the value. 83 is the value, size or magnitude. If it is plus, I am representing 0 here. Now let's take a look at a number minus 83. You look at minus 83, everything between plus and minus 83 is the same. The magnitude is the same, but minus 83 is negative. So the most significant bit, I am putting it as 1. So this particular 0 and 1, which is on the left side or on the most significant bit side, is known as a sign bit. So sign bit is used to represent whether a number is positive or negative. So in the sign and magnitude representation, one bit is used to represent the number is positive or negative. The rest of the bits are used to represent the magnitude, value or size of that particular number. Now, once we have taken a look at size, sign and magnitude representation, let's try to understand one way of trying to represent a number using ones complement. All right. So I'll show you how we represent a number using ones complement. So first, in ones complement, let us consider a binary number 1010000. If I have to find a ones complement of this number, from each of those binary bits, I need to subtract 1. So this is how I do it. So above each bit, I put a 1. 1 minus 0, 1. 1 minus 0, 1. 1 minus 0, 1. 1 minus 1, 0. 1 minus 0, 1. 1 minus 1, 0. So this particular number in ones complement is this particular value. This is a little cumbersome. There is a much more simpler method. All that you have to do is, if you have to take a binary number and represent it in its ones complement, make ones as zeros and 0 bits as ones. So now if you see, this is the number. If I convert this bit 1 to 0 and 0 to 1, 1 to 0, then 3 ones here, you will see that this will give you the same value. So here if you see, I have flipped or turned every 0 to 1 and 1 to 0. So now if you see, this answer matches with this answer. So if you are asked to find the ones complement, take the binary number and flip the bits from zeros to 1 and ones to 0. Let's take the 2's complement representation. Okay. The advantage or the drawback of ones complement is plus 0 and minus 0 will have two representations. So try to represent plus 0 and minus 0 in ones complement. You will know they'll have two different values, whereas we know plus 0 and minus 0 is the same. They are meaningless. So in order to overcome the drawback of ones complement representation of plus 0 and minus 0, the 2's complement representation was found out, where there is just single representation for both plus and minus 0. Now let's take the same number. Okay. So if you have to find the 2's complement of this number, it's quite simple. you need to first get the ones complement of this. Ones complement of this fellow is going to be this much. Okay, 0, 1, 0, 1, 1, 1. And to that you need to add 1. So what happened here? I got ones complement of this number happened to be here plus 1. When I add it, I get this number. So 2's complement of this fellow happens to be this fellow. Now, this is the answer. Let's see how we did it. So we had this was the original number. We first found out the ones complement. Ones complement was 0, 1, 0, 1, 1, 1. Now we need to add 1 to it. So 1 plus 1, 0 with a carry of 1. 1 plus 1, 0 with a carry of 1. 1 plus 1, 0 with a carry of 1. 1 plus 0, 1. 1, 0. So here if you see, this and this fellow matches the same. That means the answer is the same. So this is the right way to do the 2's complement. Take a number, flip the bits, convert from positive to negative. Sorry, convert ones to zeros, zeros to 1 and add 1 to it. That's how you get 2's complement of a number. Now what I'll do is, I'll try to show you a way of representing a number minus 14 in 3 different ways. I'll try to represent minus 14 in sign magnitude way. I'll represent minus 14 in ones complement as well as minus 14 in 2's complement. Okay, so here let's move this chap up. All right, so here we go. I think here it is. This should be better off. Okay, consider minus 14 in 8-bit memory location. So if I take 14 and I represent it in, okay, if I take 14 and I represent it in 8 bits, it is going to look like this: 4 zeros and 1, 1, 0. Suppose I have to represent minus 14 in sign magnitude. I will make this leftmost bit 1, everything else remains the same. So in sign magnitude, what I have done is, I have represented minus 14 as the leftmost bit or the most significant bit, which happens to be a sign bit as 1. The rest of the 7 bits I have used it as a magnitude to represent the number 14. This tells me that this part is 14, this 1 tells me this is minus. So the sign bit tells me it is negative and this magnitude tells me it's the number 14. Now let's try to find the ones complement representation of minus 14. So in order to find the ones complement representation of minus 14, you will take the signed magnitude representation of the number minus 14 and you will simply flip ones to zeros and zeros to ones. So if you see here, I have taken this, I have flipped. 1 became 0, rest of all this 0 0 became 1 1 1, this triple 1 became triple 0, this fellow became 1. So this is the ones complement representation of minus 14. If you flip this back, if you change this 0 to 1 and 1 to 0, you will again get this particular representation in sign magnitude form. Now let's try to represent minus 14 in 2's complement. If you have to represent minus 14 in 2's complement, there is a very simple way. First you take 14 and represent it using 8 bits. So this is the 14 representation of 14 in 8 bits plus 14. In order to make it minus 14, what you have to do is take the ones complement of 14. So now if you take ones complement, this zeros became 1, this fellow 0 0 1. So in 2's complement, you will take the positive number, find the ones complement of the positive number, okay, and then add 1 to this. Once you add 1 to this, you will see 1 plus 1 0 with a carry of 1, 1 plus 0 1, rest of all remains as it is. So this is 2's complement representation of minus 14. You can see here, this is 2's complement representation of minus 14. So just to summarize, in sign magnitude, take the positive number and just flip the sign bit to represent the negative number. In ones complement, take the signed magnitude representation of that negative number and flip the bits. This is how it gets represented. Now in 2's complement, you will take the positive number, get the ones complement number, add 1 to it, and you will get the 2's complement of a negative number. So I hope this is clear and helps you understand the basic concept of representing positive and negative numbers in a computer.